In this lecture, we'll continue our look at dynamic JavaScript objects. Let's look at lines 17 through 31 in our diagram now. Here we create a couple of string objects as guinea pigs. And then on lines 20 through 22, we add a new function to S1. We may add new functions anytime we like to our own or to library objects. Traditional OO programmers find this even odder than adding data properties, but it's the same principle. A hash table is a hash table. The new function we create, as you can see, returns a string that is the first letter capitalization of the context object string. Look up substring if you need to understand how this works, and be sure you see how the code is operating there. On line 24, we use this new function successfully to print capital A, B, C, as you can see down here in our output. But I commented out the line 25 that would try to use that on S2 because it would result in a runtime fault. There is no capitalize function for S2. This is even odder from a traditional object-oriented standpoint. Now, two different objects of the same class, so to speak, can have different functions if one has been tweaked and the other has not. And to make the story complete, nothing prevents us from replacing or even deleting existing functions, even ones supplied by the libraries. On line 26, I replace two uppercase, at least for S2, with a version that's somewhat more colorful. And you can see the results from the print on line 29 here. S2.toUppercase results in that. Now, for the time being, I have line 30, which is a different topic, commented out. It has to deal with the next block of code on lines 33 through 40. Those lines add a concat_all function to the string constructor. Line 42 shows a use of the new function down here. It concatenates an arbitrary number of string arguments into one big string that it returns. We'll look at how it does that in a moment, but first note that concat_all should not be a member of the string objects themselves, such as S1 or S2. It needs no string context object to do its job, and thus it's more akin to from-care code than it is to uppercase. In a traditional object-oriented language, it would be a static function of the class. In JS, that makes it a function property of the constructor. It could be a global scope function, but grouping it under the constructor avoids putting it in global space and indicates that it's part of the club, even if it doesn't belong to any one object. The upshot is that we can adjust the library constructors to add new static, so to speak, functions as well, or to replace existing ones. Okay, so question 1 here. Now that string concat_all is set up, can I uncomment line 30 and try it out? Why or why not? And the answer is, coming back from a pause, I can't, because not because there's anything wrong with string.concat_all, but because at line 30 it doesn't exist yet. Remember that JS scripts, including setup of new functions, are executed top to bottom. It's tempting to think that lines 33 through 40 are some kind of general declaration of the existence of string.concat_all, as they would be in a language like C or Java. But quote-unquote function declarations in JavaScript are executed code, and they don't apply until they've been executed. So down here I can call it, but up here I can't yet. String.concat_all takes an arbitrary number of parameters. As you can see in the code, I call it a second time here with only 3 parameters, just to make the point. And in the output, it works for either case. Functions that take varying numbers of parameters are called variadic. Many languages, including C and Java, allow them. Consider C's printf, or Java's system.out.printf, for instance. But JavaScript does more than allow them. In effect, it requires them, because every JavaScript function is potentially variadic. The parameters declared in the function header, recall our vocabulary, those are formal parameters, are there to give names to what is passed to the function so that you can use it. JS formal parameters don't have types, of course. They merely show how many parameters of any type the function is prepared to receive and make use of. And they don't constrain the number of actual parameters. Those are the ones passed from the caller, right? If the caller omits actual parameters, perhaps passes only one to our example here, the unmatched formal parameters are simply set to undefined. And if the caller passes too many actual parameters, then the extra ones simply don't have matching formal parameters and are ignored, at least for the moment. But how does all this work with variadic functions then? If I have to declare some number of formal parameters, right? And it can't be right for every case if any number of actual parameters might be passed. How would I declare string.concat_all with 100 formal parameters to cover the possibility of a 100 parameter call? To deal with this, we declare no formal parameters, as you can see is the case for string.concat_all. Instead, we use the arguments object, as on lines 36 and 37 here, which is a built-in local variable for every JavaScript function, which contains the actual parameters that were passed in a sort of array. Indeed, at a glance, arguments would seem to be an array, since we use its length property and we index it. But it's not quite the same thing. It has no push or pop function, for instance, the way an array does. Still, to a close approximation, it's an array of the actual parameters. And on lines 36 through 37, we're using it as such, concatenating all the actual parameters into a big string that we then return. The arguments object, by the way, has other properties that give interesting information about the call, for instance, including the name of the calling function, if it has a name, and other such data. Here's question 2. Our findMatches function, if you may recall it from the mastermind program, and go back and look in the notes at that for the benefit of this in-lecture question. You recall, and you can see in the notes, that it used two Boolean arrays to mark which guess and model letters had been used in matches. Review that code and come up with an elegant way to eliminate those two Boolean arrays and to maintain the used information without any additional variables. And coming back from a pause, one good way would be to attach the used status as a property to the letters in the model and guess arrays themselves. They are strings, recall. But note, the letters are currently native strings, elemental strings I should say, not string wrappers. So we'd need to directly create string objects via new string to go in the guess and model arrays, and then this would work. Otherwise, any property assignments would be to transient wrapper objects, right?